quick web search for stoichiometry will predictably bring you right to the term's Wikipedia page. Here you can find a better description of stoichiometry than those provided by just about any chemistry textbook. I recommend you spend a little time here and take a close look. Stoichiometry is a central part of chemistry that examines and calculates reaction and product quantities in a chemical reaction. Basically, anytime we have a balanced chemical reaction, such as this one down here, stoichiometry becomes a calculation tool that allows us to analyze how much product we can get from any amount of reactant, or vice versa. If we have a certain amount of product, we can go back and predict how much reactant we started with. For example, if you had a specific amount of nitrogen and a specific amount of hydrogen, you could predict exactly how much ammonia you could make. Or, if you knew how much ammonia you had, you could go back and predict how much nitrogen was required to make that amount of ammonia. Before we can start using stoichiometry to predict all sorts of information about a chemical reaction, we need to pick up a couple more tools. We need to know the formula or molecular weight of the substance we're dealing with. Only then can we calculate the mass percent of every element within the compounds. Using that information, we can calculate a unit of actual quantity. We call that the mole. Once we have that information, we can actually start to make predictions about a chemical reaction. This is where stoichiometry really comes into play. If a reaction's gone to completion, is there anything left? Do we form all product, or maybe there's some unreacted reactant that remains? Our limiting reactant calculations will tell us all about that. Our percent yield can tell us exactly how good our process is. Very important thing for industry and all sorts of fields. Lastly, empirical and molecular formulas need to be calculated correctly in order to properly perform stoichiometric calculations. We'll be doing that too in this unit. So let's get started by looking at formula and molecular weights. These two terms basically mean the same thing. Formula weight, though, refers to an ionic compound, while a molecular weight refers to a molecular compound. You might need to go back and check your nomenclature to tell the difference between those two things. The sum of atomic masses of atoms in a chemical formula, well, that just means that every single atom of every element within a given compound needs to be summed up to give the total mass for the compound or the substance. Now, formula weight, which refers to the weight of an ionic compound, cannot just be a standalone weight. Recall that sodium chloride or any other ionic compound exists in a network within a lattice structure. It doesn't just float around by itself like a molecular compound might. So just keep in mind that a formula weight will always be reducible down to the ionic formula. So for example, NaCl, sodium chloride, you would add Na and Cl masses to give you the total formula weight for one NaCl formula unit. Now for molecular weight, it says here it can be used to refer to molecules that can exist independently, but we can just think of it as referring to the weight of any given molecular compound. That is something that does not have a metal or ion present in the compound. Here's an example of formula weight. That must mean that we have an ionic compound. In fact, this is magnesium hydroxide. Hydroxide is a polyatomic ion with a -1 charge. Magnesium is a positively charged cation with a +2 charge. Therefore, we need 2 hydroxides to neutralize the one magnesium. Well, this is one formula unit of magnesium hydroxide. We can see that the one magnesium has its own mass of 24.31 AMU. Each of the 2 oxygens in the 2 hydroxides have 16 AMU each for 32 total, and the 2 hydrogens, a little over 1 each, equal a total of 2. That means the formula mass is going to be the sum of all of those masses, and we get 58.33 as the formula weight of magnesium hydroxide. So let's try a quick quiz. What are the molecular or formula weights for the following? We have here carbon dioxide, CO2, and here's iron 2 chloride. You might need to check your nomenclature to be able to write that formula.